Everything that begins must, at some point, come to an end. We live in a universe that had a beginning, a moment of birth, an explosion of energy and possibility we call the Big Bang. From that moment, everything we know has unfolded. Galaxies spinning, stars igniting, planets forming, and life, our life, emerging to ask questions no other creature can. But for all its brilliance and complexity, the universe isn't eternal. It's easy to forget that. We look up at the night sky and see what feels like permanence. The stars seem fixed. The cosmos appears endless. But in truth, everything we see is temporary. The stars are burning through their fuel. Galaxies are drifting farther and farther apart. Even time, as we understand it, is part of a process that's slowly unraveling. And so the question naturally follows, how does it all end? It's not a question meant to scare. It's not even one we ask out of fear. It's something deeper, something rooted in awe, in the desire to understand the story we're part of, even if we're only here for a blink of it. Because while the end may be far, far beyond our reach, trillions upon trillions of years from now, its shape, its rhythm, and its silence are already being written in the movement of galaxies, in the cooling of space, and in the dark energy pressing outward on every corner of reality. Some theories suggest a slow fading, where stars die and black holes whisper into nothing. Others speak of a dramatic unraveling, where even atoms are torn apart. And there are those who imagine a kind of cosmic reincarnation, where the universe collapses only to be born again, over and over without end. What's remarkable isn't just that these endings are possible, it's that we can even imagine them. That from our tiny corner of the cosmos, we dare to think about the death of everything. This isn't just a story about how it ends. It's a story about scale, about entropy, about time, and about us. Because even in the face of something as vast and final as the death of the universe, we are still here, thinking, wondering, reaching. So as we begin this journey into the farthest future, into the deep silence that may await all things, remember this: the stars you see tonight are ancient. Their light is a message from the past. But the question we ask now, it stretches into the future. A future none of us will see, but one we all, in some small way, belong to. Let's begin. If there's a way the universe is most likely to end, this is it. Not with a bang, not with a rip or a collapse, but with a whimper. A slow, patient erasure of everything we know. It's called heat death, also known as the Big Freeze. And though it sounds gentle, almost quiet, it's one of the most haunting conclusions imaginable. If there's a way the universe is most likely to end, this is it. Not with a bang, not with a rip or a collapse, but with a whimper. A slow, patient erasure of everything we know. It's called heat death, also known as the Big Freeze. And though it sounds gentle, almost quiet, it's one of the most haunting conclusions imaginable. The universe is subject to the same rule. Ever since the Big Bang, the cosmos has been moving toward greater entropy, a state of increasing disorder. And over time, that shift changes everything. Right now, the universe is alive with energy. Stars are burning hydrogen into helium. Galaxies are swirling with motion. Black holes are feeding. But all of that requires fuel, and fuel doesn't last forever. Eventually, stars will burn out. Some will explode into brilliant supernova. Others will quietly collapse into white dwarfs or black holes. And when the last star flickers out, the universe will enter what scientists call the degenerate era, a time when the only light comes from the slow cooling of fading remnants. No new stars will form. There won't be enough gas. Gravity will no longer have fresh material to sculpt into brilliance. Galaxies will become graveyards of stellar corpses, white dwarfs, neutron stars, and black holes slowly orbiting each other in the cold silence. But even that isn't the end. Over unfathomable stretches of time, even white dwarfs will cool into cold, dark black dwarfs. Black holes will begin to evaporate through a process called Hawking radiation, losing mass bit by bit until even they vanish. And what's left? A universe that is vast, empty and dark, a place where no energy flows because everything is the same temperature. No stars, no planets, no motion, just a thin soup of particles drifting through space. This is what physicists mean when they say the universe will reach thermal equilibrium, a state where entropy is maximized and no work can be done. In essence, nothing can happen anymore. But here's the truly staggering part. We're talking about timescales so immense, they almost defy comprehension. The current age of the universe is about 13.8 billion years. The era of star formation will last a few trillion more. But the time it takes for black holes to evaporate? Try a number with 100 zeros after it. Heat death isn't an event, it's a process. A slow erasure, a dimming of the lights. Not all at once, but one by one, across eons. It might sound bleak, but there's something strangely beautiful about it too. The idea that all things, even stars and galaxies, follow a life cycle. That the universe has a rhythm, a direction, a story arc. And while we may only witness the tiniest sliver of it, we are, right now, living in the era of light and structure. The golden age of the universe. The time when stars still shine and galaxies still dance. In a cosmos destined for stillness, that makes this moment all the more miraculous. Because one day, far beyond our time, the universe may settle into its final chapter. A cold, dark silence stretching into infinity. Not a catastrophic end, but a soft, inevitable fade. Not all endings come slowly. Some arrive like a storm, sudden, violent, and unstoppable. The Big Rip is one such possibility. It doesn't creep in over trillions of years like heat death. It accelerates, it builds. And if it's true, then one day, the universe won't fade away quietly. It will be torn apart, piece by piece. To understand the Big Rip, we have to return to a mysterious force at the heart of our modern understanding of cosmology: dark energy. Dark energy is the name we've given to something we don't yet fully understand. All we know is that it's pushing the universe apart, and it's doing so faster and faster. It's the reason distant galaxies are receding from us, not just drifting, but accelerating. It's as if the fabric of space itself is being stretched more and more with each passing moment. And no one is exactly sure why. Now, if dark energy stays constant, as current models suggest, it will keep expanding space forever, just at a steady rate. That would lead to heat death, like we discussed before. But what if dark energy doesn't stay constant? What if it gets stronger over time? That's the idea behind the Big Rip. In this scenario, dark energy doesn't just push galaxies apart. It grows more intense until it overwhelms all the forces holding the universe together. At first, it's galaxies. They drift too far apart to interact. Then, as dark energy grows stronger, it starts pulling apart galaxies themselves. Stars no longer bound in clusters, planets ejected from orbits. Eventually, even solar systems are ripped apart. The gravitational pull that keeps Earth circling the sun, gone. But it doesn't stop there. As the repulsive force of dark energy increases, it begins to overpower the electromagnetic force holding molecules and atoms together. Atoms unravel. Protons and neutrons are torn apart. Even space-time itself breaks down. And all of this could happen in a very specific order, with the final moments unfolding in a blaze of cosmic chaos. Scientists who model this scenario predict a timeline that ends with what's known as the cosmic doomsday, a moment when the universe hits an unstoppable tipping point. If this theory is correct, everything that exists would be shredded in a fraction of a second, and there'd be nothing left, not even the fabric of space to fall into. This isn't just poetic speculation. It's based on real equations, on the behavior of dark energy as we currently observe it. Granted, most data suggests that dark energy is stable, but we don't know that. It could change, it could fluctuate, and if it does, even slightly, the universe may not fade into silence. It may rip itself to pieces. It's a terrifying vision, not just because of how violent it is, but because of how inevitable it would be. There'd be no escaping it, no warning, no last-minute escape plan. But like so many things in cosmology, the Big Rip isn't just about destruction. It forces us to reckon with how little we understand the energy that makes up most of the universe. Roughly 68% of everything around us is dark energy. It fills space. It controls the fate of the cosmos. And yet, we don't know what it is. We can't touch it. We only see its effects. The Big Rip reminds us that even something invisible can end everything. And maybe that's the most profound lesson, that we are adrift in a universe held together by forces we barely comprehend. And one of those forces might be pulling it apart at this very moment. It won't happen tomorrow. It may never happen at all. But it's out there. A possibility written in the equations. A silent countdown that may or may not ever tick to zero. And if it does, the universe will end not in cold, but in chaos, ripped from the outside in, until there's nothing left to tear. There's a kind of ending that doesn't wait. It doesn't unfold over trillions of years or build up with the tension of cosmic acceleration. Instead, it arrives unannounced, without drama or warning. And when it does, it doesn't just destroy galaxies or stars. It erases the very fabric of reality. This is the unsettling possibility known as vacuum decay. To understand it, we first need to talk about something called the quantum vacuum. Now, when we say vacuum, we usually think of empty space, nothingness. But in quantum physics, empty space isn't truly empty. It's alive with energy, constantly fluctuating with particles popping in and out of existence. It's more like a simmering field than a blank void. Our universe, as far as we can tell, sits in what's called a vacuum state, a kind of lowest energy configuration of space. But here's the terrifying twist. What if this state isn't the true lowest possible state? What if we're in a false vacuum, a kind of temporary, unstable state that only appears stable, until it isn't? Think of it like a marble resting in a shallow dent on a hill. It seems settled, but it's not in the lowest point of the landscape. One small push, one little fluctuation, and it could roll down into a deeper, more stable valley. That's what vacuum decay would be. A sudden, catastrophic shift from a false vacuum to a true vacuum. A new state of reality with a lower energy level. And when it happens, it wouldn't be gentle. It would release an enormous burst of energy, expanding outward at the speed of light, rewriting the laws of physics as it goes. This is what physicists call a vacuum bubble, and once it forms, there's no stopping it, no escaping it. The bubble would grow relentlessly, swallowing everything in its path. Inside, the constants of nature could be completely different. Particles might not behave the same way, atoms might not form, chemistry could break down. In short, nothing we know could survive. Not just matter, not just life, but the very structure of the universe itself. And the scariest part? We wouldn't see it coming. Because the bubble expands at the speed of light, we would never detect it approaching. One moment, the universe would seem normal. The next, everything would be gone. There'd be no pain, no fear, no time to react, just instant erasure. Now, before you panic, it's important to remember that this is a theoretical scenario. It's based on our best understanding of particle physics, especially the Higgs field, the same field responsible for giving particles mass. When scientists discovered the Higgs boson in 2012, it gave us more insight into the vacuum structure of the universe. Some interpretations of the data suggested that our vacuum state might be metastable, meaning not truly stable, just long-lived. But the keyword here is might. Other interpretations suggest we're fine, that our vacuum is stable, or that any vacuum decay would require energy conditions that are impossible to reach naturally. Still, the idea is chilling, and not because it's likely, but because it's possible. Vacuum decay shows us that the universe isn't a fortress. It's not built on unshakable foundations. Even the thing we take most for granted, reality itself, could be vulnerable. It forces us to consider the nature of existence in a whole new way. Not just the end of things within the universe, but the end of the universe's very blueprint. A cosmic reboot, a rewrite of the rules. Some physicists even wonder if vacuum decay has happened before, if other regions of space have already been consumed by these destructive bubbles, far beyond the reach of our observation. And if that's the case, is it only a matter of time before one reaches us? Maybe, or maybe not. The universe has lasted this long, after all. The conditions required for vacuum decay could be so rare that it might never happen during the entire lifespan of the cosmos. But the possibility is there, hanging quietly in the background, not with the cold stillness of heat death or the chaos of the Big Rip, but with the eerie silence of sudden disappearance. It reminds us that not all threats are loud, and that not all endings give you time to say goodbye. Vacuum decay doesn't tear us apart. It simply changes the rules, so nothing like us can exist at all. So far, we've looked at endings that are cold, violent, or sudden. But not all cosmological theories accept that the universe dies and stays dead. Some propose something far more intriguing. That death, in the cosmic sense, might just be a reset button. This idea, beautiful, speculative, and ancient in its roots, is that the universe may be part of a cycle, endlessly oscillating between birth, death, and rebirth. In other words, this isn't the first universe, and it might not be the last. Let's rewind for a moment. The Big Bang, as far as we can tell, was the beginning of space, time, matter, everything. But what came before the Big Bang? It's a question that traditional cosmology leaves unanswered, because time itself, as we know it, began with that moment. However, some theories suggest the Big Bang wasn't a beginning at all. It was a bounce. In a universe dominated by gravity, matter might eventually slow expansion, halt it, and begin to contract. This is the opposite of what we see now, an expanding universe driven by dark energy. But if dark energy were to weaken or change in character, it's theoretically possible. Everything would collapse inward. Galaxies would draw closer. Stars would fall into black holes. The entire universe could shrink into a single, dense point, not unlike the conditions that preceded the Big Bang. And then, boom. Another Big Bang, another expansion, a new universe born from the ashes of the old. This is the cyclical universe model, also known as the Big Bounce theory. It proposes that the cosmos is eternal, not in the sense of being unchanging, but in the sense of constantly being reborn. Time wouldn't be a straight line from beginning to end, it would be a loop. There are variations of this idea. Some suggest that each cycle of the universe has slightly different physical laws, meaning every bounce leads to a slightly different kind of reality. Some might be stable, others might be chaotic. Maybe only a few are capable of supporting life. Others suggest the laws remain the same, but the arrangement of matter changes. Stars, galaxies, civilizations coming and going like cosmic tides. The math behind these models is complex and still speculative. They depend on advanced physics, quantum gravity theories, and in some cases, concepts we haven't fully developed yet. But they're rooted in a very human instinct, to believe that nothing truly ends, that there's always something next. Another fascinating version of this comes from physicist Roger Penrose, who proposed something called conformal cyclic cosmology. According to Penrose, the universe becomes so stretched and empty over time, so dominated by light and structureless radiation, that it begins to resemble the initial conditions of the Big Bang. Time, in a strange twist, loses meaning in this extreme future, and when it does, it becomes possible to map the end of one universe onto the beginning of another. It's not a bounce in the literal sense. It's more like a cosmic handoff, a passing of the baton from one era to the next, where the final state of one universe sets the stage for the next one's birth. If true, this would mean our universe carries faint fingerprints of the one that came before it. Some researchers have even claimed to find subtle anomalies in the cosmic microwave background, patterns that could be signs of collisions from a past universe. Though none of this is confirmed, the idea is compelling. The concept of a cyclical universe isn't new. It echoes ancient philosophies from across the world. Hindu cosmology, for example, describes the universe as undergoing endless cycles of creation and destruction. In Greek philosophy, time was sometimes imagined as a circle, not a line. Even in modern psychology and storytelling, we find comfort in the idea of renewal, of rebirth, of death giving way to life again. And maybe it's not just metaphor. Maybe it's real. Maybe we are living in a universe that is one chapter in an infinite book, turning pages in silence, one cycle at a time. It's hard to say whether this idea is more hopeful or more humbling. On one hand, it suggests that nothing is truly lost, that even when this universe ends, the grand narrative continues. On the other hand, it makes our universe feel less unique, one iteration among countless others. One breath in a much longer rhythm. But maybe both can be true. Maybe it's in that cycle, in that rise and fall, that we find something profound. A cosmic heartbeat that doesn't stop, even when worlds do. We may never know for sure. We may never witness a bounce or remember the universe that came before ours. But the idea that death isn't final, that it's simply a transformation, a doorway, offers a kind of cosmic comfort. Because in a universe that recycles itself, nothing is ever truly gone, only changed, only waiting to begin again. From the cold hush of heat, death, to the violent tear of the Big Rip, from the eerie silence of vacuum decay to the poetic rebirth of a cosmic cycle, we've ventured through the many ways our universe might meet its end, or transform into something entirely new. Each theory we've explored tells its own kind of story. Some are slow, almost peaceful. Others are catastrophic and sudden. Some offer finality, while others suggest an eternal loop, where the universe is born, dies, and is born again. And as strange, distant, and even terrifying as these possibilities may seem, they all share something in common. They remind us that the universe is not static. It is evolving. It has a past, a present, and, whether it's cold, chaotic, or cyclical, a future. But perhaps the most profound realization isn't about how the universe ends. It's about where we stand right now. We are alive in a moment where stars still shine, where galaxies still swirl, where the laws of physics allow for life, thought, and wonder. That in itself is extraordinary. In the grand story of the cosmos, we occupy a small, bright chapter, one that is fleeting but deeply meaningful. Because despite all the vastness, all the math, all the mystery, the story of the universe's death isn't just about the cosmos. It's about us, about our desire to understand, to imagine, to find our place in something so much bigger than ourselves. Maybe we'll never know exactly how the universe ends. Maybe no one ever will. But asking the question connects us to the stars, to time itself, and to the fragile beauty of existence. So whether the end comes in darkness, in fire, or in a cycle that begins again, we were here. We wondered. and that wonder will echo as long as thought exists. Thank you for joining us on this journey across time, space, and the final horizons of possibility. If this video made you pause, reflect, or see the universe in a new light, please like, share, and subscribe to the storyteller Panda for more journeys into the mysteries of science, space, and existence. What do you think? Which theory do you believe is most likely, or most beautiful? I'd love to hear your thoughts in the comments below. Until next time, keep asking questions, keep exploring the unknown, and keep your eyes on the stars. Because in a universe that might one day end, this moment is everything.